In this second upskill session, we are going to talk about classes. In my experience, what I have observed is most of the students, despite being into schooling coaching system for more than 13-14 years, they are unable to figure out that what is the purpose of attending the class, what is the correct way of attending the class, and what should be the outcome of attending a class. So what I've felt is, at the end of the day, despite the teacher teaching really well, student paying attention in the class, since they are unaware what to get out of that class, largely speaking, most of their problems have their roots in how they attended the classes. So today we are going to address the root cause of all evil in any kind of preparation. That is nothing but how to attend classes. Now, if I ask you a very simple question at this point of time, to start this discussion, that why do you think we should attend classes? What is your perspective that this is the reason we should attend the class? Think over this for a moment, because this is going to be critical when we come on to my idea of why we should attend the class. Now, according to me, if I move forward, these are the reasons that the student should attend a class. So a class should serve the purpose that your concept should be very clear. It should serve the purpose that problem solving technique should be there in place. It should serve the purpose that your thought process, how to take that subject forward, what should I need to do as a student, should be very clear. And ultimately, I should develop a dialogue around it. That would mean how it connects with other topics, other subjects. Now, coming back to the first idea. What do we mean by concepts? Because this is one of the most commonly used words in your preparation. Every faculty will come and tell you, is your concept clear? What is the concept behind it? This concept will apply to solve this problem. But what does this word concept means as such? So according to me, the word concept has two meanings. One is basically what and another is why. So for example, I am taking any topic, for example, quadratic equation. So I should understand what is a quadratic equation. That would mean what is the definition. A definition is nothing but all agreed upon assumptions that each of us believe, on which the subject is developed. So the first thing that should be very clear is nothing but the definition. Now, whatever conclusions you are going to draw should not be just based on your rough understanding of the idea. It should be solidly based on what is the definition, because definition is the minimum element of truth that is there in whatever you are thinking, whatever you are assuming. So if your definition is not clear because of XYZ reason, so what will happen is, whatever conclusions you are going to draw, those conclusions are not going to be right. So in order to develop the subject in the right manner, to draw right kind of conclusions, the definition should be very clear. You should always remember the definition. If this part is into place, then the what part of the concept is fixed. The next part of this idea would be to know the why. Now, what is why? So why would mean two different things. One is basically in terms of logic. What is the logic behind the concept? So I should understand what is the logic behind a formula, a concept, what is getting taught, a subtopic, topic. And more tangibly, especially in case of physics, we should also understand what is the derivation. Because you will see that whenever you know the derivation, you will have a different sense of clarity altogether. So in order to have a sense of clarity and interest in the subject, it also will help you develop interest. That would be required you to do this topic, because faculties and students will say that I should study this many hours in a day and I do this many things in a day. But if I have no interest in what I am doing, how can I put that much amount of time consistently over a period of 2, 3, 4 years? It is not possible until unless you are interested in it, and that interest is only going to come if you are very clear with the logic and the derivations of that topic. So consisting both of these ideas, what and why, will concept the concept. Now, if you are taught in such a manner that both of these things are clearly told to you, and you have put attention towards both of these ideas when they were taught to you in the classes, largely we can say that the class has served its first purpose, that your concept is clear. Now moving on the next idea. The next idea is basically problem solving technique. See, this is ultimately what we will want to do. In paper, nobody is directly going to ask the concept. Sometimes it does, but largely speaking, it is not going to happen. They are going to ask you these things using problems. So, for solving problems, we should have problem solving technique into place. Now, how to develop problem solving technique? That is the question that most of the students will have in their mind. So, there is a systematic process. Now, whenever somebody is teaching you, what they will do is they will take multiple illustrations to deliver the idea of problem solving. Now, few teachers are very clear like me who will tell you what are the standard problem types. And how these problem types will connect with each other to become more complex problems. Some of them will not be that much clear. So what you need to do is, when you are solving a problem, you should observe. What you should observe is what is exactly changing from one illustration to another, and what are the things that are not changing. So you can see that whenever there is a problem, there are two things. One is the dynamic ideas, and there is another part, that is the static part. So once you understand it in this manner, you will see that the dynamic things will keep on changing, but there is some static structure to that solution that will always remain same. If you are able to understand these two things, you will be able to understand how the problems are getting developed and what is the thinking process behind that. Now we have understood what to observe in a class. Now if I move further, once you have observed these illustrations, the next part should be what you should do at home. So if I come back to home, I should start attempting questions. Now the idea should be, you should first start with attempting those illustrations that are already solved in nature. So a very good starting point would be to go back to those class illustrations and try and solve on your own. And now once you're solving, now that parts that you observed in the class, those dynamic part and those static parts, try and apply those and try and solve these class illustrations. Then slowly move from class illustrations to solved examples. And from solved examples, once you have stratified your strategy, then you can move towards nothing but unsolved questions. So this should be a strategy. Start from class illustrations, apply those ideas, dynamic and static concepts that you have learned in the class. Then move with the same ideas to solved examples, because when you are solving the solved examples, the solution of that question is available. So in case you have gone wrong in one or two steps here and there, you can observe it. Then you can move towards more unsolved questions. You can see that this becomes a more scientific way of learning problem solving. Now once you are doing, there are few things that you should keep an eye for. First is basically the answers. What I have seen is faculty will have this nature ki ab ye ho jayega. They have that kind of attitude. They will tell you in the class ki after this step now you can solve. But you should not do that as a student, because if you do not pay attention to answers, in the long run your answers will not come and your accuracy will get affected in the exam. So if you have this problem of accuracy in the exam, lot of those problems can be traced down to students not getting to the answers and not being very serious to the answers when they are doing their practice. Now, once you have developed this logical way of solving the questions, you have got an analogy into play. Now remember that most of us are not born with inherent ability to solve problems. This is something that can be systematically learned if you observe and attempt questions. If you are able to follow these two steps and more importantly observe in the class and then do it, largely everybody, you, me, anybody can learn this skill set. Moving forward, now let us come to the third important process in the class, that is nothing but the thought process. Now most of the times what I have seen is students will be very tangible about the concept. They will be very much particular about their problem solving technique. But most of them will miss out to these two next steps that are there in a class. One is nothing but developing the thought process. So what I have seen is students will not have a coherent thinking process in a subject. I will tell you what do I mean. See, you might have gone to a maths faculty after a class and asked this question, sir, this question I am unable to do. So then he will refer back and say that, beta, this question is based on that question that we solved in the class. You can see that as an answer to a question, he is telling you or referring to another question that you solved in the class. While if you ask the same question to a physics faculty, his answer would be different. He will say that this question is based on this concept that we did in that class. But if you go to a chemistry faculty, he will straightforward say that, Arey, I have given you in my class notes, it is there. So what does this shows? This shows there is an inherent thinking process into place in all the three subjects. Now what is that thinking process? Let us look into this. So what is happening is, when you are doing a subject like physics, here in physics it is an analytical subject. What does that mean? This subject fundamentally is based on logic. So if your logics are very good, largely you will see that marks, practice, everything will start happening in the physics. And even if you're not getting the answers in practice, you will understand why those answers are not coming and what you can do to build up that subject. See if you can do that. You should understand why my answers are not coming, why I'm not understanding something, and what can I do in order to improve that. Then you have got the thought process. But if you're clueless how to move forward, you do not know why your answers are not coming, then probably your thought process is not into place. So what you can do is, as a student is, when you're doing physics, observe that it is an analytical subject. Understanding is of key importance. So rather than directly jumping onto the problems, it would be a very good idea that your definitions, derivations should be in place, and a very logical way of thinking process like that it is there in a physics faculty, you should also have it. If you are able to do that, then you can start with gradual problems which has lower level of difficulty and then move towards more and more difficult problems, and understand that how much logically you are able to extend an idea in solving problems. So if you are able to develop this thinking process, you have fixed your physics subject. Next, moving on to the chemistry part. Now if you go to chemistry, it is largely an empirical subject. What does that mean is, there is a lot of data into place and you have to remember the data. That would mean, if I look into topics of inorganic chemistry, organic chemistry, the important thing is you should understand what are the most relevant set of data. So faculty will teach you a lot. Chemistry faculties have this habit, they will teach you a lot of data. But as a student, if you understand which is the most critical of those data, from what 20 to 30% data most questions will come from, master that and remember that. So remembering and revision of class notes becomes very important. The physical chemistry will largely behave like the physics did. So remembering is the key. If you forget what was taught, especially in organic chemistry, you will see that things will start piling up. And after a certain point of time, you won't be able to understand anything. Now moving towards the math. Maths is an abstract subject, it came out of problems. So idea is that if we can see every question as a combination of different kind of problems that we have learnt elsewhere, largely your mathematics will become very good. So the key skill set is to identify a finite number of standard problem types in a topic. Like in Practise, we teach it using this methodology of problem type 1, 2, 3, 4. And then how can we divide a more complex problem into those problem types and connect them to get an answer. If you think like that, maths will become very interesting, very simple, you will enjoy it. But if you take this physics analogy and you apply it here, it becomes a tragedy. If you take mathematics idea of problem solving, apply it to physics, it becomes a tragedy. So you can see that most of the students are facing this problem in one subject because they are taking other subjects thinking process and applying it to the next subject, and they are trying to get their answers. And when you apply this physics thought process into mathematics, it will work with a very basic level. Basic questions you can do, but at a higher level of problem solving, it will not work. Similarly, maths problem solving, if you apply into physics, you will find that you will not understand what is actually happening, why, where I am going wrong, because there are not problem types exactly in physics. It is more logical expansion of the concept of derivations. So in class, first two things would be taught, but this third thing you will have to observe. Some faculties will do tell you, but most of them will not tell you. So you will have to observe these things, and this will change from topic to topic, section to section in every subject. So you will have to go into the details and understand and decode it. If you are able to do that, by doing less also you will be able to produce a lot of outcome. Now moving forward, here comes the most important part. See, I have seen that if I ask this question to most of the students that, okay, you have done a chapter, okay, you have done a chapter, how does a chapter looks like? So they will give me, okay, I am going to do quadratic, they will tell me 4 or 5 topics that are scattered in random order. So what happens for most of the students, they have a watermelon kind of a model of a topic in their mind. There is no organization into it, there is no story into it. So remembering those things that you did by attending the classes, doing practice, writing tests, that will become very difficult. So largely speaking, when we are learning, it is a very good idea that we make it into a story. So idea would be, what should understand what is the moral of the story. So what is the chapter trying to express? Okay, and how the things are getting connected. When the first concept came, then what is the second idea that came, how they interacted, how the story got developed, what can be the next ideas that can come into the picture, why they are asking certain type of questions more, what should be expected in terms of problem types. You can see that it is like a story. Then if you are able to build this story, you will also understand that why are the problems getting framed and what could be the next set of problems that can be asked. You can see that most of the people are thinking of it as like facts and figures put here and there, some kind of data that they need to remember. There is no sense of story into it. If you understand like a story, how things are getting mixed, intermixed, new problems are getting generated, you will see it will become very interesting. You will understand chronology of things, you will understand why certain kinds of problems are important and what else they can ask in the topic. So it is very important to develop a dialogue around it, a story around it. It should not sound like a piece of bits and pieces and a sewn together of information sewn together. It should feel like a coherent story. And if it becomes like that, it will be very easy to remember, very interesting to learn, and you will develop a lot of interest in your classes. So now, what is the ultimate test? So what we have learned, let me summarize and then go to the ultimate test. So what we have learned so far is there are few important ideas. The first one was nothing but concept. Concept is the first and foremost thing. I have divided it into what and why. Then we went towards the how part, that is nothing but problem solving technique. Then I came to the third idea, that was nothing but the thought process. And I told you that every subject, every topic might also have a different thinking process. The thought process is also important. And then we ended our discussion by developing a dialogue around it. So now you can understand that while we are attending the classes, these two things faculties will do, but these are the two things that students should more focus on. And what is the ultimate test once you have done this? You should develop this confidence that, okay, now this topic I can teach to anybody who comes in front of me. If you have that kind of confidence in you, I am not asking to teach somebody, I am saying that you should have that confidence. If you have this confidence that I can teach this to anyone, and it is so much clear in my mind, then you have actually got it. Then your classes have largely become successful. So now evaluate based on what I have told you, that are you attending your classes in this spirit and in this notion or not. If it is getting done in this manner, then largely you are doing very good. But in case you are not doing this, please assimilate these 4 ideas and put yourself into this ultimate test and see whether how can you improve as a student and how your outcomes can be increased in terms of limited hours of time that you are currently putting in. In the next video, we are going to talk about practice. Practice is nothing but the most core portions of JEE preparation. So do not miss out to the next video. See you until then. Bye.